What is Russell's paradox in set theory? Imagine trying to organize all the sets that do not contain themselves into one big collection. Now ask yourself, should this collection include itself? That's the core of Russell's paradox. Russell's paradox is a tricky problem in early set theory that shows not every collection can be considered a set. It starts with a simple idea. What if we create a set of all sets that do not contain themselves? Let's call this set R now. The question is, does R contain itself? If R does contain itself, then by its own rule, it should not contain itself because it only includes sets that do not contain themselves. That's a contradiction. On the other hand, if R does not contain itself, then it fits the rule to be in R because it is a set that does not contain itself. So, it must be in R, which again contradicts the idea that it does not contain itself. This paradox shows that, if you allow any property to define a set, you can end up with logical contradictions. It reveals that some collections are too problematic to be considered sets. This was a big problem for mathematicians trying to build a solid foundation for all of mathematics. To fix this issue, mathematicians developed new rules called axioms that limit how sets can be formed. These rules prevent creating sets like R that lead to contradictions. For example, the Zermelo-Fraenkel set theory with the axiom of choice, known as ZFC, restricts the ways sets can be made, avoiding paradoxes like this one. From the perspective of numbers and their patterns, Russell's paradox shows us that even basic ideas like collections and membership can lead to surprising results. It highlights how careful we need to be when defining mathematical concepts. This paradox helped mathematicians realize that the rules behind sets and numbers must be carefully crafted to avoid logical pitfalls. In practical terms, solving Russell's paradox means mathematics can be built on a consistent foundation. It ensures that number theory, algebra, and other areas stay free from contradictions caused by problematic sets. It also influences fields like computer science and logic, where understanding self-reference and definitions is very important. So, in simple words, Russell's paradox is a puzzle about whether a certain kind of collection can exist without causing a contradiction. It changed how mathematicians think about sets and numbers, making sure our mathematical universe stays consistent and reliable.